Well, greetings out there in YouTube land, and welcome to today's very special video feature in which we will dissect and evaluate an early Marshall amplifier. This is the first time that a Marshall has been entrusted to me. The viewers have been hounding me to dissect a Marshall and fix one, and so here we go. This is a 1967 Marshall JMP for Jim Marshall Products. It's a 50-watt Plexi amp with a true plexiglass dash panel. As you will see, it's in absolutely, I'd say virtually mint condition, and also has some very unusual features. Now, I don't claim to be an expert on Marshall amps. I have just done about an hour or two's research, and there's things about this amp that contradicts what some of that research tells me. So all you Marshall experts out there, and just anybody interested in great vintage amps, you better pull up a chair and see what you think of this one, okay? Because I'm telling you, this is really special. It belongs to a friend of mine who's had it for 30 years. I've been trying to get him to bring it over, and he finally did. It was like trying to get him to leave his daughter to be babysat by the Hells Angels. You know, he was very hesitant to let it out of his sight, and I don't blame him now that I read about them. So let's take a real close-up look here at it from stem to stern, inside and out, and see what's special about it, and maybe learn something about Marshall amps. Jim Marshall was a drummer who had a music store in Hanwell, England, and in 1962 he and a tech named Ken Brann began trying to design an amplifier that would rival the Fender Bassman. It would become the JTM-45. JTM stands for James and Terry Marshall. I didn't even know that. I always thought they just randomly picked the initials. And the first JTM-45 prototypes were very special amps that were very closely related to the circuit of the Fender Bassman 5F6A. There were some minor alterations in the circuit, and they used all British tubes, but otherwise they were rather close. And I think the reason for this was that it was very expensive to import Fender amps, and Marshall decided there would be a market. He had a bunch of musicians who were about to become extremely famous telling him that he needed to produce some English amps that were really loud, louder than Fender Bassman, and that could use Fender materials and be sold at a lower price. And he definitely jumped on this, and the rest is history, as they say. But let's face it, when you have Pete Townsend and Eric Clapton telling you that something to do with amplifiers is a good idea, it probably is. Now I'll go to handheld camera here so we can get some close-up views. It has that gold cord that goes all the way around the body seam, and plastic gold-colored lettering that is very fragile. But this is held up beautifully. I think there's one little break somewhere in this, but it's almost invisible. But as you can imagine, about the first time this amp got loaded harshly, this thing was probably wiped out. It's a real credit to the condition of this amp that it's here and in perfect shape. Now let's drop down here to the control panel that gives all of these Plexi amps their name, in that the material used is actually plexiglass. It's rather fragile. It was easy to work and probably inexpensive to source. They switched over to brushed aluminum in like 68 or 69, so obviously this amp then is a pre-68 or 69 because of the existence here of the plexiglass panel. Very simply said here, JMP for James Marshall Products. On-off switch, standby, a pilot light, a present switch, which we know is a type of a negative feedback circuit, bass, middle, and treble. So you really have 4 tone controls, two channels. We have volume 1 and volume 2, and then our inputs here, channel 1 and channel 2. Very, very simple. But look at the condition here of the plexiglass panel. It's beautiful. The knobs, everything in perfect shape. The person who owns this, I can tell you, has incredible taste and really takes care of their stuff. He's also a terrific guitar player, so you'll be glad to know that this amp gets used in the manner for which it was intended. Let's flip it around and take a look at the top, the bottom, and then the back. The top has some cigarette burns, and they look to me like the type where the guy would set the cigarette on end and then ignore it, and it would burn all the way down until it burned, because these are round circles. You know darn well if you lay a cigarette down flat, you're not going to lay it in the middle of the amp, and it's going to burn in a line. Okay, so I bet that's what was going on here. The original handle is in beautiful shape. Pretty classy, nice handle. It isn't just an old piece of plastic stuck between two end pieces. It actually has more like a fancy luggage type of joint here. And of course the gold beading that travels all the way around. It's a little different. This is kind of a gold vinyl, whereas the cord that goes around the front is more like a woven cloth type of gold cord. There's a good example right there where the two meet, and you can see the difference between the two types of cord. Looks like we have a mixture of brass screws here holding the chassis in. They all look old. I'm not sure which is correct. And also there's a gray rubber type of foot that's used. This one has some felt pads put on, and I noticed one of the felt pads is missing here. But in my research it said that on these early ones they had the gray rubber feet, like this one has. Okay, there's a little bit of road wear here at the bottom where this has been set down on something kind of abrasive, but when it's sitting on its feet, all that's invisible. And here's the rear view, and as you can see, it's just as nice as the front. Really beautiful shape. It has the extruded gold screen here for ventilation, and a really nice, what appears to be kind of like a vinyl or plastic tag that's still attached to the rear. I understand this is, because of its fragility, is often missing. You can read what it says. I hate it when people read to me. Like I said, so nice that it's still there and so rarely seen. Now let's go ahead and remove the wood and metal screen panel and take a look at the chassis and the rear plexi panel. And here is the chassis. I used a magnet to see, because in the research it said that the very early ones were aluminum. This is a steel chassis with the plexiglass rear panel, and as you can see, it has the Made in England logo here with the serial number S/, which means 50 watt 10346, a very low number, and I think would probably correspond to 1967, maybe even early in 1967. Okay, I like that, the little speaker logo here. And then we'll get a close-up here on how you can select the output impedance and the voltage that the amplifier will work upon. But let's just go down the line here. We've got a fuse, a special fuse dedicated for the high voltage, the B+, and also one for the AC primary, and then an altered receptacle. And I know this will drive the purist crazy. I believe this was supposed to be a round Bulgin receptacle, and it had the more modern type of computer cord receptacle installed, but the owner, who apologized profusely for this having happened, it was done before he got the amp, said he still has the Bulgin receptacle. Leave it to him. Now, before we pull out the chassis for a really close look at the top and underside, let's look at these really clever selectors. Okay, you pull out a little jumper, and that would be the common, and you can pick either 16 ohm, 8 ohm, or 4 ohm, and then plug it in. Now for your mains voltage, same thing. You've got a little jumper like this, and you have your common right in the center, and then you can connect to 250, 230, 210, or if you're in the colonies, 115, and that of course is where we're going to plug it in. So I just thought that was really clever. I've never seen anything quite like that on an amplifier. Alright, the chassis has been removed from the cabinet, and as you can see there's a really nice, fairly heavy gauge sheet of metal at the bottom here, I guess to shield from RF and electromagnetic field interference in the circuit. The rest of the cabinet's nice and clean. It looks like the holes there that were drilled to allow the installation of that plastic Marshall logo. Okay, now let's take a look at the chassis. Alright, here's the top of the chassis with a massive power transformer. I was prepared for a Drake part number. I don't think this is. You Marshall experts will know what type of transformer this is, but that's the serial number on it, or model number. And here an equally massive output transformer with its identification number, and then a filter choke with its number. Okay, another thing I really like over here is assembly, and this of course corresponds to the serial number. It looks like Joan or Lone. Could be, maybe Marshall had females assembling amps just like Leo Fender did. The AC was checked, back panel, and test. We'll never know. It's either wasn't tested or the name is lost to history. Okay, now let's turn it around and take a look at the tubes in this thing. Okay, because I think you're going to be very pleasantly surprised. Alright, I removed the tube shields from the preamp tubes, and we start off pretty high on the hog here with a Mullard ECC83, okay, which could well be an original tube. Next we have an RCA 7025, which is probably a replacement tube. Then finally another Mullard, probably the phase inverter. Now the EL34s are rather special. They're National Electronics 6CA7 EL34, made in West Germany. So you know it has to be pre-1990. Okay, so these are fairly old tubes and they're in beautiful shape. We'll see how well they're matched when I check the bias in a few minutes. But for now, that takes the cake. I've never seen any other National Electronics tubes like this made in West Germany. Very unusual. Now I believe this amp had the electrolytic capacitors changed at some time in the past few years. This may well be a replacement cap. Like I said, I'm not well versed with Marshall amps, but I have a feeling that's a replacement. Now let's take a look at the tube rectifier. I know most of you are thinking, since this is a JMP, that it should have a solid state rectifier, but this one has a GZ34 tube rectifier. And as you can see, it's marked Siemens, which I believe is German made. Okay, and it's in beautiful shape. A very unusual tube. I don't think I've ever seen a GZ34 with kind of coarse markings like that. But it was made in Germany. I'll bet it's a good one. Okay, I'm going to have to get a forklift to turn this thing over. You talk about iron. Look at these transformers. This is one heavy beast. Okay, so I'm going to set down the camera, put on my truss to prevent a hernia, and flip this beast over. Okay, I flipped the chassis over so we can see the circuit, and what a difference from some of the previous amps that I've been working on that have been, shall we say, botched, for want of a rather more brutal adjective. Look at the workmanship on this one. Now, it looks like just about every capacitor has been changed, but absolute first-class work. I know that the owner was using this amp on a regular basis for public performances and wanted it to be totally reliable, and replacing all of the capacitors was a way to achieve that. I also found that the work that was done on this was by a fairly well-known amp tech named Doug Roccaforte in California, and I believe he is an amplifier tech for people like Van Halen, Beck, Steve Stevens, and John Fogerty. And I can tell you from the quality of his work, I can see why they would go to him. This is beautifully done. I don't really see anything that I'm going to need to check in here, except let's verify that the tubes are properly biased. Okay, and there's an adjustable bias circuit here. This is the filter cap for the negative DC bias supply, and this is a trim cap that will allow us to increase and decrease the amount of negative DC that we apply to the tube grids, okay, to regulate the plate current within the EL34s. These are my bias measurements. Plate voltage was 395.8, which agrees well here with the schematic at 400 volts. You see the resistance of the two primary windings, the voltage drop across them, plate current, and rather low plate dissipation values. Now, EL34s are good for 25 watts of plate dissipation. 70% of that would be 17.5. It looks to me like the tubes are biased at about half of the appropriate plate dissipation, which seems to me about like running a 427 engine with a 2-barrel carburetor. It's kind of wasting the power potential of EL34s. I'm thinking we're going to have to increase this plate dissipation, maybe not to max, but say up around 15. Okay, and then let's see how the amp sounds. All right, using the trim pot here to adjust the amount of negative DC bias voltage that was applied to the grids of the two EL34s, I came up with this biasing here. I increased the voltage drop from minus 983 up to 1.518 and 1.64. The plate current went from 21.2 and 24 up to 32.7 and about 37 milliamps for plate dissipation of say 13 to 14 watts, which is comfortably under the maximum, and I think is going to work just fine for this owner, because he was used to this cold bias setting. He ought to be thrilled now that the EL34s are finally working at a lot closer to their potential. Now, this decision is predicated on the fact that this is a very valuable amp and I don't own it, so I tend to be very conservative. Some of you would say, oh, I'd crank it up to 18. Fine, if it's your amp, feel free to do so. But when you're dealing with other people's property, I usually find it best to be conservative. If they were happy with this setting, they're going to be thrilled with this one. There's no need to take any risks to run the plate dissipation way up to an area that might shorten the life expectancy of these rather expensive tubes. So much has been said about how Marshall amplifiers were actually based initially upon the 5F6A Bassman amp by Fender. I thought it might be interesting to actually go in and compare the two schematics to see just how similar they are, and if there are differences, why those differences exist. And during that comparison, I think it's important to keep in mind the different purposes that the designers of each amplifier had in mind for their product. The Fender Bassman was initially intended to be a bass amplifier. However, they, I think, soon realized it really worked even better with regular guitars, So they incorporated a bright channel. So they had a normal for the bass input and then a bright channel for the guitar input. This bright effect was accomplished simply by adding a 0.0001 microfarad cap here to bypass the volume control. This allowed high frequencies then to have a shortcut to the output stage and to be present in greater quantity than they would otherwise. If you're wondering why I seem distracted sometimes, look at what is meowing here right at my feet, demanding some more tuna fish, I have a feeling. Casey, you little rascal. The Marshall amp, however, was never intended for use with a bass guitar. It had a very different purpose in mind. It was created to use tubes and components that were readily available in England to produce a more powerful amplifier, primarily for lead guitarists, to just absolutely blast the audience and cut through any type of mix that was necessary. And as we will see, Jim Marshall set out from the beginning and at the very end of his circuit to do that. So let's begin our comparison. And where better to begin that comparison but with the input and first preamp stage of each amplifier circuit. The Fender input is the standard one that he used on almost all his amps, 68K grid stoppers, 1 meg grid leak, leading into two separate triodes of a 12AY7, which is a rather low output member of the 12A tube family. It only has an amplification factor of about 40 compared to a 12AX7, which is about 100. Okay, so initially the first preamp tube has a rather low amplification factor, and both of the cathodes of those two separate triodes are biased identically with an 820 ohm bias resistor and a 250 microfarad bypass capacitor. Cap. Now let's see how Jim Marshall envisioned his input and first preamp stage. Well, Jim said, you know, if I'm going to keep people like Pete Townsend and Eric Clapton happy, we better start off right away, not with a puny 12AY7, but let's go with a 12AX7. Okay, now his inputs were identical to Fender's, 68K grid stopper, 1 meg grid leak. But this choice of tube immediately shows the different intent he had in mind for the amplifier. Also, instead of a bright and normal input for a bass or regular guitar, he knew no one was going to use this thing with a bass guitar, so he went right for the throat here with a high and low input. Now notice how he treats them. It's very different. He doesn't cathode bias and bypass them jointly with a rather conservative choice of components. Instead, the two triodes are biased completely differently. The high gain input has a 2700 ohm bias resistor and a 0.68 microfarad bypass cap. Both of these are extremely conservative, whereas the low input has a more traditional 820 ohm bias resistor and 330 microfarad bypass cap. Now it may seem a little contradictory that the very conservative bias resistor and bypass cap are on the high gain triode. Yes, Casey, just a minute. Papa's busy. But if you look up here, look at the difference in the plate voltages of the two triodes. The low input is 150 volts, just the same as the Fender, but the high input plate voltage is 205 volts. So already we're sending a much stronger signal to the second stage of amplification with the high gain input on the Marshall amp. Plus, the amplification factor of this first preamp tube is 100 because it's a 12AX7, and the 12AY7 is a measly 40. Okay, so already Jim Marshall has sort of shown his intention for this amplifier, and that it is clearly different than what Leo Fender's intention was with the Fender Bassman. Now, if you recall, I said that the major differences between the two circuits are in the first and last amplification stages. All of the stages in between, component choices, everything else, virtually identical. Let's just quickly pass over them and see that is really the case. In the next stage of amplification, both Leo and Jim used a 12AX7 as a cathode follower. Now, we know that a cathode follower acts sort of like an output transformer, and that it converts the high voltage on the primary side to low voltage and high current as an output. And the reason that's done is to avoid excessive losses of the signal in the tone stack. Both of them did this, and surprisingly enough, the tone stacks are virtually identical, as are the presence controls. As you can see here in the treble, mid-range, and bass portions of the Marshall tone stack, they use a 0.0005 microfarad, whereas Leo went with half of that, 0.00025. But other than that difference, the two tone stacks are virtually identical. The Marshall presence control is part of the negative feedback loop, and it uses a 5K pot with a 0.1 microfarad cap, absolutely identical to the placement and component values as the Fender presence control. Now on to the phase inversion stage, and they're both long tail pair phase inverters, and component values, tubes, everything are virtually identical, other than one capacitor change here on the Marshall amp, 0.022, and 0.1 on the Fender. The two stages are virtually interchangeable. Now, if you want to get down to, did Jim Marshall really copy the Fender Bassman? I think, as far as the middle part of the circuit, yes. It's just value for value, component for component. As we've seen, the preamp stage of both is different, but as we'll see now, the output stage is slightly different in a very important respect. But this part here, the comparison is so direct, so perfect coincidence of values and design, that there is no doubt that the Marshall amp was copied from the Fender Bassman with certain changes to make it more suitable for its purpose. And now in the final stages of the amplification circuit, we'll see that a big change was made here by Jim Marshall, in that he used EL34 output tubes, whereas Leo Fender used 5881s. Now, I understand that the 5881s were rather expensive and difficult to get in England, whereas the EL34s are being made there and were not only readily accessible and cheaper, but also more powerful. A 5881 operating in tandem in a push-pull configuration would have to really be driven hard to put out, say, 45 watts of power, whereas a pair of EL34s can easily put out 55 watts or more if properly set up in a properly designed circuit. Okay, so the choice of tubes here was to serve two purposes: readily available, keep costs down, and also to provide the greater power for this lead guitar amplifier rather than the bass guitar amplifier that's also good with regular guitars. Also, Mr. Marshall was kind enough to provide 3 different output impedances, 4, 8, and 16 ohm, knowing full well that this guitar amplifier head was going to be used with different speaker cabinets. The Bassman was a combo amp and therefore had its own built-in speakers, 4 10s, operating at around 2.3 ohms, I believe, with a single impedance output transformer. One last area of comparison is based not so much on intent of the amp as where it was going to be sold. Jim Marshall's building his amps in Europe, where there's a great variation in power supply. So he wires the primary of his power transformer to be suitable for 110, 120, 200, 220, and 240 volts AC input. Leo Fender had no aspirations for selling in Europe, and therefore his has the single primary input of 110 to 115 volts. Despite how the Marshall schematic looks here, the one that we're dealing with today used a GZ34 tube rectifier identical to the one that Leo Fender used, and it's a great choice of rectifier. I've spoken many times about why this is the best tube rectifier I can think of. It has a very slow startup time, so it's almost like a built-in standby switch. It's very efficient. It draws very little current through the filament wiring to produce a very, very high output B+ voltage. So they both made a very wise choice in the rectifier tube that they selected. And they both provided standby switches here and here, and filter chokes here and here in their power supply. Well, that's about it for this comparison of the circuits. It was rather quick and somewhat superficial. If you'd like to go into greater detail, just download the 2 schematics yourself and look at them side by side. They might be a really good way to start to learn how to read schematics. And each time you see a change in component value or something like that, try to figure out why it would serve the purpose of the amplifier that change was made in. Now let's get back to our evaluation of the mighty JMP Marshall amplifier. Well, fans, it's time for what we've all been waiting for, is the audio demo here of the mighty Marshall JMP amp. And I thought we just can't entrust it to any old speaker cabinet, so I dragged out my custom speaker cabinet with 2 big 15-inch Jensen bass speakers and a projector horn. Okay, so I think it should be a match for the output from the Marshall amp. Also, we couldn't just use a regular old shop guitar, so we got a super nice 1963 American Fender Telecaster here. So this ought to be a pretty good audio demo, I hope. I hope you agree when we're finished. Okay, so let's get started. Ollie and Jack are just frothing at the bit here to get started. So without further ado, let's run the Marshall through its paces. Well, we got so excited about how good this amp sounded that I dragged out the old Lesley and thought this might give us an opportunity to play a song that you haven't heard in a while. Well, I guess that's about it for this video featuring the Marshall JMP amplifier. And as we look at some really pretty pictures from the area surrounding where I live, I wanted to thank my Patreon patrons and PayPal contributors for their continued support of our channel. For those of you who'd like to join them, please check the link in the video description. Also, if you liked that little compact Lesley device that was shown at the end of the video, check the video description for a link to the video in which I show how to build one. I guess that's it for now. I really appreciate your time and interest, and I hope to see you again soon. Bye for now.